intermediate, a carrier, such as clathrin-coated vesicles or other transport carriers that have been described since, which then transported these membrane proteins to the compartment where they reside within the endosomal lysosomal system. So in essence, what these interactions do is to contribute to the packaging of receptors and other transmembrane proteins within coded transport intermediates. Now, although this model was developed during the 80s, it actually took many years to identify the first signals and the first adapters. And the reasons for that were several. One of them was that the signals were not exactly conserved sequences of amino acids, but degenerate sequences that fit one of several consensus motifs. So all endocytic receptors did not share the exact same sequence of amino acids, but there were specific motifs that were encrypted within the sequence of the cytosolic domains. And in addition, the interactions of those signals with adapters were of relatively low affinity in the micromolar level. So the problem was not really tractable at the time with the methodologies that were available. And it was only in 1990 that Brown and Goldstein reported the identification of the first endocytic signal in the tail of the LDL receptor in a landmark paper that was published in JBC, Go JBC, and which is one of the highest cited papers in the field. So they found that the sequence NPXY, meaning asparagine, proline, X meaning any amino acid, and tyrosine, function as an endocytic signal for internalization of the LDL receptor and other members of the LDL receptor family. So it was in 1991, about a year later, that I was offered the opportunity of staying at NICHD and to form my own group of the tenure track investigators. And so I decided to search for an interesting problem to study as a tenure track investigator. And I consider the possibility of working on the identification of the adapters that bound to endosomal lysosomal sorting signals. I wanted to find a new project that was different from the one I had worked on as a postdoctoral fellow in Rick Clausen's lab. And I thought that this was an interesting and potentially very important problem to work on. So I then talked to some friends of mine and some colleagues about what they thought about this idea of trying to work on the identification of adapters. And I remember talking to a senior colleague of mine who listened patiently to my plans and who looked at me and told me, you know, Brown and Goldstein have been working on this problem for years and they have not succeeded, so I don't like your chances of finding the adapters. And as it turned out, this person was right, or at least partly right, because it took many years for anybody to identify the adapters that bind to NPXY signals. It was in 1999 that Jonathan Cooper reported the identification of the disabled proteins, disabled 1 and disabled 2, as adapters for NPXY signals from the LDL receptor. And only in 2001, Helen Hobbs and Jonathan Cohen, using a genetic approach, identified another adapter for the LDL receptor NPXY signal, the protein ARH. So it took 9 to 11 years to find this adapter, so this person was right. If I had chosen to work on the adapters for NPXY signals, I would have been toast, and I wouldn't be here talking to you. So what happened? Well, what happened was that at the time, in 1991, it had already become evident that there were other sorting signals that did not fit the NPXY consensus motif. And there were still no publications, but through the grapevine, one heard that, you know, the transferrin receptor doesn't have an NPXY signal and it's still very rapidly internalized. And through the work of several people, including Fred Maxfield, who will be visiting the NIH next week, and Sue Kornfeld, and also some work that we had started to do, it became clear that there was another motif that fit this consensus, YXX bulky hydrophobic. Tyrosine 2 residues, that could be any amino acid, and a bulky hydrophobic residue that could also function as an endocytic signal. And this is the signal for which we decided to search the adapter. It took us a couple of years and about 3 postdocs to finally identify the adapter that binds to this type of signal. And it was a postdoc in my lab, Hiroshi Ono, who used what was then a new methodology, the yeast-2 hybrid system, in order to identify proteins that bind to the YXX bulky hydrophobic sequences. And he found that the adapters for those signals were the mu subunits of 3 adapter protein complexes, AP1, AP2, and AP3. By then, it was also becoming clear that there was much greater diversity of endosomal lysosomal sorting signals than we had anticipated. Because in addition to these MPXY and YXX bulky hydrophobic signals, both of which contain critical tyrosine residues, when you mutated those residues, you inactivated the signals, it had become clear that there were other signals that did not have critical tyrosine residues. And it was actually in our branch, work done by François Letourneur and Rick Klausner, that resulted in the identification of another type of signal that did not have tyrosine residues, but instead had 2 critical leucine residues, and which for that reason became known as dileucine-based sorting signals. So we decided to try and identify the adapters that bound to this other type of signal, and this actually turned out to be more challenging, and instead of 3 postdocs, it took 5 postdocs, and probably as many years to fully understand how dileucine signals were identified. And what we found is that these signals were, perhaps surprisingly, recognized by the same adapter protein complexes, AP1, 2, and 3, but instead of binding to the mu subunits, they bound to a combination of 2 subunits. And now that there is a crystal structure for this complex, we know that that is because the binding site straddles the border between 2 of the subunits. Okay, but there was more. In further work that we did, we realized that not all dileucine signals were the same. That there were other dileucine signals which had an acidic residue 3 positions upstream of the first leucine instead of 4 positions upstream. And that was enough to completely change the specificity of recognition of it. Known as GIGA 1, 2, and 3. I'm not done yet. Bear with me. I'm getting to the end of this list of signals. Then a Howard Hughes medical student in my lab, Peter Voorhees, who was in my lab for only 1 year, discovered a different type of signal, acidic clusters, which could also mediate rapid endocytosis of some proteins from the cell surface. And those are found in proteins such as furin, but also in the NEF protein of HIV-1. And actually, that acidic cluster is important for NEF to be able to downregulate CD4 from the cell surface. And it was recently that a postdoctoral